Hello everyone, welcome back to your Calculus 2 class. Today is a beautiful day. Let's learn some math, okay? So today we are going to talk about the basic approaches of integrate. So these are some basic integration formulas. So please read, take your time to read, refresh your memory before we use some technique to find the integral of some complicated integration, okay? Some complicated function, I mean. So please take your time to read this. Like, you know, the antiderivative of a constant is what? Kx plus c. And the integral of x to the power of p is what? X to the power of p plus 1 divided by p plus 1. So take your time, read, and then we'll start right now. Okay, so if you look at this first example, we are asked to evaluate the integral of dx over e to the power of x plus e to the power of negative x. So by looking at this integration, we can see there is no basic integration formula that we can use to integrate this one. And if this happen, I know some of you will say, oh, this look like hyperbolic function. No, it's not, because e to the power of x plus e to the power of negative x is in the denominator, right? So if this happen, most of the time, we have to rewrite our function somehow, so we can use a substitution to get one of this one, okay? Like, for example, by looking at this one, I know even if we are using substitution, we'll just say what? Let u be equal to e to the power of x. But if you look, we have e to the power of x plus e to the power of negative x in the denominator. So my first instinct would be, let me have just positive power, right? So this is what we have. What about if I multiply and divide by e to the power of x? Why am I doing this? So I will not have any negative power. If I do that, I will get what? E to the power of x divided by e to the power of 2x plus 1 dx, right? So now I will use my substitution. I will say let u be equal to e to the power of x. If u is e to the power of x, then du will be what? E to the power of x dx. And that's what we have in the numerator. So my integral will become what? I will end up having 1 divided by u squared plus 1 du. That's what I will have. And if you look at my integral, this look like what? This one, right? The dx over a squared plus x squared, which is what? Tangent inverse. So I know my a is 1 because 1 squared is 1. So I will have, this will be equal to tangent inverse of u plus c, because a is 1, right? And what is our u? E to the power of x. So my final answer will be tangent inverse of e to the power of x plus c. And that's it. So you see, I have to rewrite so I can use substitution. So let's move on to the next example, which is integrate cosine of x plus sine cube of x divided by dx, right? So in this case, I need to simplify or rewrite, because you can see we do have only one term in the denominator, right? We have only one term in the denominator. But in this case, we do have two terms. So that's why I have to simplify this like that. But in this case, you know, I can set my integral cosine x plus sine cube of x divided by secant x dx is exactly the same thing as the integral of cosine of x. Let me use a parenthesis, divided by secant x plus sine cube of x divided by secant x dx, right? Or we know 1 divided by secant x is what? Cosine x, right? So this is just like what? This is just like cosine square x, right? Plus, and for plus sine cube, because again, 1 divided by secant x is cosine x times cosine x dx. So I can separate this one to two integral, right? So it's just like I would be solving two integral. Can say this is same thing as the integral of cosine square x dx plus the integral of sine cube of x times cosine of x dx. That makes sense. So you know we don't have the power of trigonometric function integration yet, right? So you have to use one of the identity to break this one down. Which one can you use? Think about half angle. We know cosine square of x is same thing as 1 plus cosine of 2x divided by 2, right? Divided by 2. And then if I'm integrating this one, I can use a substitution, use substitution for the second. So we have two integral to integrate. 1, 2. The first one I will use half angle. The second one I can use substitution. But I will do all of them in the next step, so you will see. So now, of course, we can break this one down also to 1/2 plus 1/2 cosine of 2x dx, right? And then using a use substitution here, I will just say let me use a red pen so you see what is happening. Or let me bring this one down a little bit. So So 1/2 plus 1/2 cosine of 2x dx plus, now for the second integration, I will say let u be equal to sine x. Then du will be what? cosine of x dx, right? And that's what we have. So I will have plus u to the power of 3 du. And now we are going to go ahead and integrate both. So we will get what? This will be 1/2 x, right? The antiderivative of cosine of 2x is what? 1/2 sine of 2x, and 1/2 times this 1/2 will be 1/4. So I will have 1/4 sine of 2x, and the antiderivative of u to the power of 3 will be, this one will be 1/4 u to the power of 4. But what is our u? Sine x. So plus 1/4 sine to the power of 4 x plus c, and that's it. Right, and that's it. So you see, I use what? Try to simplify, and by simplifying, I have to use some trigonometric identities and then find my solution. So practice, okay? Practice make it perfect. So now let's move to the next one. So for this one, we have to find the integral of x squared plus 2x minus 1 divided by x plus 4 dx. So when integrating a rational function, which means a polynomial in the numerator and a denominator, we first have to check to see whether the function is improper, which means the degree of the numerator is greater than the degree of the denominator. And in this example, we have an improper rational function. And whenever you have that, you use long division first to simplify. Long division means what? You divide x squared plus 2x minus 1 divided by x plus 4 dx. So you have learned that in college algebra. If you forgot, please practice. We have to divide what? Let me do that right here. X plus 4, which is the division, x squared plus 2x minus 1. And then when you are doing long division, we look at the first degree, which is x squared, and on the divisor we have x. What do you need to multiply x to get x squared? That is x, right? So we multiply by x. X times x is x squared. X times positive 4 is 4x. Don't forget u minus x squared minus x squared will be canceled out, right? And now 2x minus 4x is what? Negative 2x. And then we bring this negative 1 down. We bring this negative 1 down. Now, what do you need to multiply x to get negative 2x? That is negative 2. Negative 2 times x is negative 2x. Negative 2 times positive 4 is negative 8. Don't forget we minus. Negative and negative will be positive, so this will cancel out. Negative 1. Negative and negative will be positive. Negative 1 plus 8 is 7. What's the degree here? 0. What's the degree here? 1. So you can see the degree of the divisor now is greater than the remainder. So you leave it like this. So this means what? Again, I'm going to do my integration in the other parts, okay? This means my x squared plus 2x minus 1 divided by x plus 4 is same thing as x minus 2, right, plus 7 divided by x plus 4. That's what it means. Okay, so which mean basically, since I have improper integral, so I mean improper rational function, so I will set my integral x squared plus 2x minus 1 divided by x plus 4 dx is exactly the same thing as x minus 2 plus x minus 2 plus 7 divided by x plus 4 dx, right? And then now we can go ahead and find this integral. We know if you want, we can separate this to two integration as well, or you can do it as one, because you, by looking at this one, you need to know this is what? ln, right? You can see on your basic integration formulas, you have it. Dx over x is what? ln of x. So du over u is what? ln of u. So that's what I will apply right here. Okay, but again, I can rewrite. So for you to better understand, I'm going to make it to integration x minus 2 dx plus, if I want, I can take this 7 out to make it 7 times 1 divided by x plus 4 dx. So you would see this one will be 1/2 x squared minus 2x plus 7 ln absolute value of x plus 4 plus c, and that's it. Okay, so let's go to the next one. We have to find the integral of dx over square root of negative x squared minus 8x minus 7. So again, if you go back and check your basic integration formula, you will see we do not have something like this. So what do I need to do? So I know it involves a radical term. Or if you look on my basic integration formula, I only have radical when it's what? Science inverse, right? The integral of. So I have to rewrite this function somehow to get this term. So to do that, you can see we have what? A squared minus x squared under the radical right here. So that's something I need to do right here. So again, by doing just one, most of the time you don't get it. So let me divide again. What we have is what? Negative x squared minus 8x minus 7. So first thing, my goal will be to make this one the difference of two perfect square, right? So what I will do first, I can see all of them is negative. It's hard to work with a negative term, right? So let's factor this negative first. So I will have what? X squared plus 8x plus 7, right? And then I'm going to make this one a perfect square. Or you know what? Let me change it and just factor 8x Sorry, my keyboard is not working. I'm trying to erase. It's not letting me erase it. Okay. Again, what I was saying is I'm going to factor negative on these two terms and then minus these 7. So you remember how to complete a perfect square, right? So this is 8. So we divide 8 by 2 and add square of that. So we'll be adding 4 square. But if I add 4 square, it's just like there was no this 4 square here, which is what? 16, right? Minus. So I have to minus 16 square, right? But since this will make it minus, so I have to also add 4 square. Do you understand? Because it's like we minus 4 square, we have to add 4 square. So it's just like we haven't add anything. And if you check, this will become a perfect square, which will be what? X plus 4 square. And negative 7 plus 4 is what? 4 square is 16. Negative 7 plus 16 is 9. So this will be plus 9. So basically we'll have what? 9 minus x plus 4 square. Do you see it? So it gave me, which is what? Like 3 square minus x plus 4 square. Right? So that's why if I'm asked to find this integral, which is dx over square root of negative x squared minus 8x minus 7, I can say this is the same thing as dx over square root of 9 minus x plus 4 square, right? In this case now, what is my a? My a is 3 because again, as I said, I can set is, oh, we can set this is same thing as the integral of dx over square root of 3 square minus x plus 4 square, right? So my u is x plus 4 and my a is 3. So this one will just give me, by doing substitution now, look, because I don't want to do it without substitution. So you can see, I can say let u be equal to x plus 4. So which means my du will be dx, right? So what we have doing my substitution now, I will have du divided by square root of 9 or 3 square, because I want you to see your a, 3 square minus u square. So which will give me sines inverse of u divided by 3 plus c. What is our u? X plus 4. So my final answer will be sines inverse of x plus 4 divided by 3 plus c. That's it. I hope you enjoyed this section. Let's go to the next one.